Hello, today we are going to discuss solving simultaneous equation. We have discussed previously in the last session of the computational physics finding the root of an equation. Today we are going to extend it for a case where we are going to deal with more than one variables, more than one unknowns, because the previous case was to deal with the cases where we had a single variable. Before we go to learn how to solve equation or a simultaneous equation, you all know that equation is basically a statement that the value of two mathematical expressions are equal. You can see different kind of the equations, like if you see a common equation A is equal to B plus C, that represent that the two sides, the right side is having two variables and they are connected with a addition operator, and then the result is assigned to the variable at the left side, which is A. But that's a generalized kind of the equation. We can have a lot of equations in physics. For example, if F is equal to ma, the Newton's second law, that's an equation that represent a lot of physics behind it. That's basically a mathematical model. Any equation is representing a model that is showing the relationship between the variables, between the physical quantities. So you can see the similarly different equations, the quadratic equation, you can see different equation containing other operations, integrations, differentiations, square roots, functions. You can see the gravitational law, you can see the laws of equations of motion in the physics, you can see a lot of equations in electrodynamics, in nuclear physics and quantum mechanics, but actually they all are representing some sort of physics behind it, because they are connected with each other and they are representing the relation. They are modeling some situation, some actual situation, some physical situation, which you may need to express in a long text, in a paragraph form. But when that is represented in the form of an equation, the situation is very much simplified. That's called a mathematical model. So there are different problems in not only in physics but also in chemistry, in engineering and in other branches of the sciences, where you need to model the situation to represent the situation, actual situation, in a mathematical model, where you may need more than one equation. For example, you can see that to calculate the electric current flow in an electrical network, where you have a lot of resistances are there, different currents I1, I2 and I3 are to be known, for example. Similarly, in nuclear reactor dynamics, in to find the stress in different structures, to find the flow rates in interconnected hydraulic systems, to estimate the reactant concentration in chemical chain reactions. These are some examples where you need to model according to the situation. There can be more than one variable, that can be two, that can be three, that can be even up to n. And then we have number of equation also increased, not only the variables but also the equations, so that these are called simultaneous equations. So these are the set of equations where we have to find out more than one variables which are to be known. If you are going to explain it to a common person, you can explain it to a common man as well. We are talking about physics right now, but if a common man wants to understand what is the concept of a simultaneous equation, this is an example. Like if two people are there, one man and a woman, so if the man buys for example 3 fish and 2 chips, and the value the price he pays is 2.80 pounds, and the woman buy 1 fish and 4 chips and she pays 2.60 pounds. Now if we are interested to know what was the individual price of fish and chips, because there are two different things purchased in the different quantity or a ratio by the two different people, we can we can model it in a way that we can estimate the value of both the variables, which are fish and chips in this case, because the two people have paid differently. But now we can, with the help of that information, this is possible that we can calculate the value of both the variables, which are f and c. And you can see there are two options, elimination and substitution, and ultimately you can see in this slide that this is the value of fish is 60 pence and the value of chips is 50 pence, so that they are going to satisfy both the equation. Similarly, a very simple example, let me start with a very simple example, that if you are given two equations, For example, there are two variables. When they are added, the result is 10, and when the difference is taken, the result is 2. So what are those two variables which are going to satisfy both these equations? So there is only a single choice, and these variables are 6 and 4. When they are added, you will get 10, and when they are subtracted, you will get 2. There is no other combination possible in this. This is a case where you have two equations and two unknown, but that can be increased as well, 3 equations and 3 unknowns, etc. Before we go to understand it more, for example, we are going to solve the equation actually when they are plotted in a graph, so they represent something. Every function when plotted, for example, a function containing the two variables at x and y, so when that function is plotted, you will always get a different kind of the curve. So that is the exclusive curve for that function. We have different kind of the function we deal with. You can see them like and they are divided in, for example, linear function, when the relationship is like y is equal to x, or y is equal to x plus 3, x minus 3, or something like that. We have logarithmic functions where you can see such graphs. We have exponential functions where we can see a rapid kind of the increase. We have polynomial functions, quadratic functions, power functions, rational functions, sinusoidal functions. These are the functions commonly, and when you draw them, when you plot them, you can see a curve over there. But now we are talking about the simultaneous equation. If there are, for example, two equations, so when you make the curve, when you plot both of them, if they have some simultaneous equation, they must interact somewhere. If these two curves are not going to intersect anywhere, so we can claim that there is no simultaneous solution existing. But you can see in this example, which we have just discussed, that the two variables where sum is 10 and the difference is 2. So if they are plotted individually, you can see these two straight lines are obtained, and they are going to intersect only at a single point, which is 6 and 4. You can see another example where two functions are represented. One is plotted in blue color, and the second one is plotted in the purple color, and that's a case where we have two possible set of the solutions over there. And similarly, this is a list of the functions of the two variables and two equations, and the solution is also represented in the right side of the right column of the table, where you can see different situations. But that can be extended for a case when we have 3 equations and 3 unknowns. For example, this is a problem, you people have to solve it. The problem, there are 3 equations: x plus y minus z is equal to 1, 8x plus 3y minus 6z is equal to 1, minus 4x minus y plus 3z is equal to 1. When this is solved, you will get the result, which is x is equal to 2, y is equal to 3, and z is equal to 4. I'll be explaining later that how can you solve it. But before that, we need to point out, we need to understand 3 general characteristics of such equations. The solution set of 2 equations in 3 variable is usually a line. In general, the relationship, the behavior of a linear system is determined by the relationship between the number of equations and the number of unknown. For example, if a system has fewer equations than unknown, this has infinitely many solutions. For example, if x plus y is equal to 10, this is one equation and 2 variables, so this equation has infinite solution. You can see 1 plus 9, 2 plus 8, 3 plus 7. There are so many numbers. When they are added, you can get the result 10. So when the number of variable is more than number of equation, then that will have some infinite solution. Another case is when the number of equation and the number of variable are unknown are equal, and that will be the case where we have a single unique solution. And a system with more equation and then variable than the variables has no solution. These 3 characteristics are very important to understand and to apply. So you can see, if you have a single equation that will have a plot, we don't have much concern in that. We have 2 equations, so if we claim a simultaneous equation, they must be intersecting somewhere. And if that is the case, for example, that is an example where we have 3 equations, but they are not going to agree on a single point. They don't meet on a single point, though any 2 of them are intersecting, but not all the 3 curves are intersecting at a single point. So that's the case where we have 3 equations, but they have no solutions. This is another example, 3 equations, but they are not intersecting, so that will not be simultaneous equation. So let me give you some example that you will have to solve. For example, this you should be noting them, the cases you will have to solve. You will keep the screenshot or the picture of this, and then you will have to solve. How will you solving it? You will have to write it in a generalized format, and that is the general format to write an equation in this way. You need to have the constant coefficient first and then the variable. In the previous discussion we have used the variable x, y and z, but in a general way it's recommended that you should be using x1, x2 and x3, x4 and so on, so that the case will be limit free, and that can be extended to the n variables, and that can be extended to m equation. And on the right side of the equation you will have the constant coefficients, and once they are there you can write them in the three matrices. The first matrix will contain the constant coefficients, the second will contain the variables, and the third will contain the right side of the equation, which are the B matrix. So Ax is equal to B, the formula will be used, and then you will be writing them in a single matrix, and then you start to operate row operations and the column operation, and ultimately you will get it in an upper triangular matrix. The lower triangular part should be 0 and the upper triangular part should be non-zero, and then you start the back substitution, starting from the calculating the value of the last variable. In the case of the 3 variable, that will be x3. Once you determine the value of x3, then go to the previous equation, the middle one, you can get the value of x2, and then you can get the value of x1. So in this way you can, using the back substitution, get the values of all the variables. So I am leaving this with some examples for you to be solved. First you need to solve these equations, and then we'll be making a program in C++ or to apply this technique in the MATLAB to determine the solution of the equations, and then we will be able to get the solution of simultaneous equation, where we have a lot of situations in physics where you need to model the situation. You need more than one variables, and that will not be a difficult task. Once you understand it, once you do it manually, that will not be a tough task. And we will be discussing about how to write a program in C++ to do the same assignment. Thank you.